Alright, so on here, you guys have already got some data, but here is my data. Now, which data do you think you should use?
Yours.
Why mine?
Like you said, you use the fancy scale.
That's right, I use fancy scale. I use fancy stuff. So in that case, you're going to use what I'm using. So I'm going to give you a second to get this information down, and then I'm going to show you how we're going to get the rest of this. What's coming around right now to talk about those sheets is one of them has a new data table on it so that you can fill this information in fresh and new. I'm going to show you here where we're going to get this percent sugar off these labels. I was bothered by it whenever I started looking at it, and I said, something is wrong here, and then I figured out what was wrong, and I said, man, how could I have made such a simple mistake? Mr. Hall, oh no. And then, I'm going to show you how to use a lovely program called Excel. You need Excel to get things to work properly for you. There's Speak 2 coming around. Looks like they're piled right up on that desk if anyone wants to reach over and get them. You should have 2. I have one set cover page if anybody needs this. They need it? Fantastic. Wonderful. I have the other one too if you need it. Very nice. Nobody needs it. Very good. Alright, in this, so you all know how I got the mass solution, and like we said before, we just straight up made this volume of solution 10 milliliter all the way through. And this is beautiful, okay? While you're copying this down, I'm going to talk about how we got this density of solution here. So if you just use the units, and you'll see, it's grams per milliliter. So density is equal to mass divided by volume. And that's all we did on every one of those, okay, to get what I'm putting here in this thing. I messed up. Girl, white out. Hold it. I hate this white out. This is the stupidest one.
Mr. Hall?
Yes.
What's not the paper? The mass? Is it 366 or 361?
1.361. I apologize. That's grams per milliliter. Then we have 1.0237 grams per milliliter. Then we have 1.0425 grams per milliliter. 1.0595 grams per milliliter. We have 1.0827 grams per milliliter. We have 1.026 per milliliter. I messed up again. The heat in this room is killing me. Grams per milliliter, 1.0485 grams per milliliter. Then we have 1.0423 grams per milliliter. 1.0425 grams per milliliter. 1.0355. I don't know if that really helps there. Okay. Alright, so there's that little tidbit of information for you. And all this information that's here, I'm going to be putting it, like I already did it in second period, so that information's there. If you guys need to go back and watch that video, that sheet looks a lot better. Starting off, just being honest. Alright, then in this, you all had this great question. Everybody was trying to figure out how
Donnie Fortner, please take a mop to room 1028. Need to see Christian Purdue in the office.
how we get this information right here, these blank spots. I'm going to tell you that's where Excel is going to come in at. For us to be able to find this, we're going to have to use Excel. Okay, and I'm going to show you what you can use Excel to be able to do with it. Now, going outside of that, okay, you need to know how you've calculated how I got these solutions. Okay, how I made this 1% sugar solution, 5% sugar solution, 10% sugar solution. How I got all these. And I'm going to simply make it easy for you, okay, so that y'all know. I did this all based off of 1,000 milliliters. So I took 1,000, and then I looked at it and said, what is 0.01 of that? Because that's 1%. Alright? And I found that to be 10. Whenever you do that, that's the mass of 10 grams of sugar. And that's what goes in 990 milliliters of H2O. You need this. Should be another one sitting right there on top of the place, right there actually. And this is 10, okay? Then from there, for everything else, I'm just going to go on and give it to you. I'm not going to spell it out. I showed you how I did that one calculation. Everything is still based off that, but we're changing this number here. That number is what would change. So when we're talking about 5%, this would be 0.05. And whenever I did that, I found it to be 50 grams of sugar in 950 milliliters of H2O. And this is just how we was making these solutions. Well, I made the solutions, okay? You need that information whenever you're writing this report. So you got 100 grams of sugar in 900 milliliters of water. 150 grams sugar in 850 milliliters of water. Then we did 200 grams of sugar in 800 milliliters of water. That's how we got these solutions up here. Okay, that 1%, 5%, 10%, 15%, 20%. That's literally how I made it. I measured out 10 grams, 50 grams, 100 grams, 150 grams, 200 grams, and I put them in 990 milliliters, 950 milliliters, 900 milliliters, 850 milliliters, and 800 milliliters. All right.
Traquan, come to the office. Traquan.
And whenever I did that, these are for 1%, 5%, 10%, 15%, and 20%. Okay, that's how we got these numbers, these solutions. That's where we got all that information from. Now from here, whenever you're looking at this, the other piece of information that we can find here. Remember what I told you, this highlighted portion We find the highlight portion off Excel. We'll show you how to do all that. But from here, this percent sugar off label, okay? A lot of y'all were trying to figure this out, and I'm going to tell you, don't make the mistake I made. On these bottoms, see where it's got that percentage next to total carbs? It says 24%. That is not the percentage we're looking for. That percentage is your percent daily value. We have to calculate this out. So in this Dr. Pepper, you are getting 24% of the carbs that you're supposed to get in one day. That's not good in case you didn't know that.
How many carbs are you supposed to have a day?
It's based off of 2,000 calorie diet, and I can't remember the breakdown of the macromolecules off the top of my head. Oh, fuck. That's gonna help you. So in this, we're going to calculate this stuff out, but I got to show you how we did this, okay? So to get the percent sugar, I'm going to do it in this lime green. Off label. You got to do a calculation, okay? This calculation is very simple. You're going to take the mass of sugar, off label, you will divide it by the volume of the bottle, or can. We're looking at bottle. And you will multiply that by 100. So that's how we're going to make this calculation here. So as an example for it, I'm going to show you straight up for Dr. Pepper, okay? So on this, I'm going to show you how you find it with Dr. Pepper, and we're going to calculate it out. So on here, on your Dr. Pepper bottle, you see here where it says total sugars? We're not just going to look at that total sugar. We're going to look right here where it says total carbs, where it says 66 grams. The reason we're doing that is because when you're looking at carbohydrates, they break down into sugars. So we're taking all these carbs into account. So there's 66 grams. So for Dr. Pepper, you got 66 grams. And that's divided by, how big of a bottle is this? 20 ounces, but do we use that in this science class? No. Look right here. Milliliters is what we use. So divided by 591 milliliters. I'll focus that back in for you. And you will multiply that by 100. That whole quantity is getting multiplied, okay? You're not just taking that 591 multiplied by 100. If you do, you're going to end up with some problems. And you should get 10.9983% sugar. And up here, because I don't have all that room, what I'm going to put is 10.9983%. Okay? So after the Dr. Pepper, we have Coke. So let's look at the Coke bottle. It's a little harder to focus it in. So what do we have Coke-wise?
65 grams.
65 for total carbs. And what's the volume? 591. So 65. I'm going to use a calculator. I should do it from the phone. So 65 divided by 591. times 100 is 10.9983%. Alright, in this case, we're going to the monster, okay? And in this, if any of you are being bothered by what we're doing right now and you're thinking, shouldn't we be doing this by serving size? Yes, we absolutely should. But whenever you look on these labels, all these labels are saying that the serving size is one bottle. And you can see here, the serving size is 1 can. So in this, we got to find our total carbs. 58, you can see it. I'll focus it in. So 58 grams, that's the total carbs we're looking at. You're dealing with a 16 fluid ounce can, so you're dealing with 473 milliliters. Okay, so you take that, do that math, and you will find Monster to be 12.262%. 12 point, what's part? Volume?
58 grams, 473 milliliters.
473. So you get 12.2622%. Then the Mountain Dew. Do, man. Mountain Dew. Total carbs, 77 grams. Whoa! 3 ounce bottle, so 591 milliliters. Do the math.
What was the grams?
77. I find it to be 13.0288%.
What's the number of those? Can you like say the number? God.
Is that better?
Okay, so what you would do is you do the balls are up there, but you just pretty much take the total grams of sugar and then total grams and all, divide it, and then times it by 100.
Yeah, that's literally what we're doing, but that's
Okay.
like only on the carb section, because like on here you also have sodium. So we wouldn't be doing with the sodium. We're just looking where it says total carbs or sugars. That's what we're looking for. And my personal fave, I like this one so much I bought an extra bottle of it so that I could drink it, and it was not the one you had in the lab that I drank. Apple juice. Come here. Focus. Total carbs, 41 grams. In this case, you're dealing with a small bottle. You're dealing with 12 fluid ounces, so 355 milliliters. So you'll take that 41 grams and divide it by that 355 milliliters, and you will find it to be 11.5493%. So now we have that percent sugar off the labels.
You times it by 100.
Yeah, you times it by 100. Now here's the key that I got the question. The 1%, 5%, 10%, 15%, 20% solutions that were made, do we have labels for them? No. So you don't need any of that information here. You're not going to calculate out any percent errors here. So now you got a full data table. And I will stress to you also when I say this, these data tables, these handouts I gave you guys, I'm not going to give you another one. You need to keep up with them. You guys are in chemistry. Y'all definitely need to be able to keep up with this stuff. So that's where all that's at. And you need that data table. And let me show you why you need that data table, ladies and gentlemen. Oh, man, my head. How many of you ever used Excel before? Fantastic.
Oh, man.
Alright, so in Excel, here's the ultimate thing that you're looking and trying to achieve. You're trying to get this graph. Now with this, I'm going to show you how you're going to get this graph. Before I do that, I probably need to... Okay, notice some things about this graph. It has a title. Not only does it have an overall title, it has a title for the y-axis and a title for the x-axis. You must include all of that, and not only that, but over on the right they have a key for the diagram. You need that. So I'm going to show you how we're going to get that. So everybody do a favor, say bye-bye to the graph, and it goes away. Alright, on here, give you a breakdown of what I've done. Hopefully you're to the point where you can at least type in Excel. Okay? Remember, we'll be going to the computer lab tomorrow, and we'll be working on this the rest of the week. You'll have plenty of time to get this stuff together. Okay? In this, all I've done is I've typed over in here the solution mixture. Okay, and I've put all the solution mixtures in here. So 1% sugar, 5% sugar, 10% sugar, 15% sugar, 20% sugar. And then I even put the soft drinks that we did. So Dr. Pepper, Coke, Monster, Mountain Dew, and apple juice really in a soft drink, but I threw it in there just because I thought something with some natural sugar would be interesting. So from there, I have grabbed information from these solution mixtures. So percent sugar concentration. 1, 5, 10, 15, 20. Then from here, I took the density of those solutions. 1.0061, 1.0237, 1.0425, 1.0595, and 1.0827. Please notice that in all of these, I have my units there. Okay, over here, percentage is technically the unit, so yeah. Here's how you're going to do this. Okay, and I know you probably never have made a graph whatsoever in Excel, so this is the interesting part. And we're recording this so you can go back and watch it later on to see how to do it if you have questions. And you'll have me in the lab, so if you have questions there, you can ask me. But what you're going to do is you're going to click, we're going to left click on the bottom number that we're looking at. So left click, and we're going to hold, and we're going to drag over and go all the way up. We're going to highlight all that information. Once you have all that highlighted, that's me telling Excel, I want you to pull for this information. So, once you have the information highlighted, you're going to go up here at the top where it says Insert here at the top left. You're going to click on Insert. Now when you go there, over here are all these charts you got. Over here in this area. Okay, you see where it says Charts? There's Chart. Now think about what you're ultimately looking for here. I'm going to go on and tell you what we're trying to find is a relationship between percent sugar concentration and the density of those solutions. And we're going to try and get a formula from it so that we can use that to work backwards from getting the density to find the percent sugar concentration of our soft drinks. And that might have confused you because that was a whole lot of things going on there that you probably never heard of before. So let me show you what we're doing. You need to choose something that makes sense. I'm going to tell you right now, bar graph does not make sense. So we wouldn't use a bar graph in this case. If we were trying to show, the percent sugar concentration and which one had the most, then yeah, a bar graph makes absolutely great sense, and I highly recommend it. But in this case, we're wanting to do a scatter
Been
plot.
lane to the office.
So on here, we're going to go to the scatter plot, and it's the one that looks right here. It's got that X and Y axis with those dots on it, because that's literally what we're wanting to do here. So we're going to click on it to go down. Click on the little drop down arrow next to it, and here's your different types of scatter plots. We definitely don't want one with lines through it. We're not after a curved line like they got there. Okay, and we don't want to, definitely are not looking to connect the dots. We just want one that's got dots on it. So you can just see that one there. And we're going to click it. Ta-da! We have a graph. Is there issues with our graph? Yes, there is issues with our graph. What are the issues?
They're probably not in actual order. Can you be?
They're in order.
The dog's in the right place.
Do what?
It's not gonna make it straight around.
If we connected the dots, it wouldn't. We're going to deal with
It's
that.
not labeled.
It's not labeled. In this, let me show you. Here's the image, okay, guys? Like what we were looking for. I printed this off earlier. Ultimately, this right here is what we're after. And that's going to come from that line of best fit, which I'm getting ready to show you how to do. But here's the important thing. It has a label here. Has a label here. Has a label here. I'm horrible at highlighting. Okay? Those labels are crucially important. I need to know what this x-axis is about. I need to know what that y-axis is about. I need to know what the graph is about. And I need to know what's these dots mean. What's the linear? What's that line about? And I need that formula because you're going to work backwards with that formula. So in this case, let's flip back the computer. I'm going to show you how to get all that stuff on there. Alright, so on here, we already got us a lovely little title graph. Okay, title for the graph. That's the proper English we're looking for. So I'm going to click on the graph. And over here at the top left where it says Add Chart Element, that's where you're going to be looking to add all this information in. So you're going to click on it and it's going to give you some drop-down menus. So in this case, we got some axis titles. We need those, so we need to add those in so we can name them. So you see primary horizontal, and it drops right down there to show you that it's going to label that x-axis for me, which I need that. I also need to get a y-axis, so the vertical axis needs. So let's go back to this Add Chart Element. You're going to drop the arrow down, go to Axis Title, and we're going to add a primary vertical, because then it's going to label that vertical axis, like it has there. Now with these, let's go on and label these. I waited later on in second period. Let's go on and label these. What is that y-axis?
Density of solution.
Something about the solution. Not the sugar concentration. Take the hint. Density of solution. So, we'll call it density of solution, and hopefully you all make sure and put your units. Those are important. You catch that, okay? Y is the y-axis, the same as the actual title of the graph. That's a great point. So let's change that. We'll double click on here. Density of sugar solutions. And you really don't need that grams per milliliter in there. I left it in second period. If you do, it's all good. I'm going to leave it because I like units so much. I'm weird like that. Okay? And then in here, we're going to call this x-axis. What's the x-axis going to be called?
Percentage of sugar concentration.
Percentage of sugar concentration. Or you can just call it percent of sugar. If you put percent of sugar concentration, it's totally fine. I'm just going to put percent sugar. And if you're really a big of a neat freak, you can put your percentage in there as your units. If that makes you feel better in your life. All right, then from there, we're missing some things. So, what are we missing?
The line of best fit.
Line of best fit. So to do that, you're going to go up here where it says add chart element. Hey, have you guys found like where you go to add these chart elements yet? You're going to go down here and you're going to find this thing that says a trend line. Okay, now in this trend line, we're not dealing with an exponential function. We're not dealing with moving averages. We're not dealing with any of that. We're dealing with a line. We want a linear representation. So you can go over to this trend line where it says linear, and you're going to click on it. Now, does anybody see a problem with that trend line right now?
It's completely off.
It's not completely off. It's split the difference between them. It's giving me a pretty good representation of what I got. There's something that's driving me nuts. My skin is crawling right now.
It's a dotted line.
What?
It's a dotted line.
Dotted line, it drives some people nuts. It doesn't drive me nuts, though. You can change it if you want to change it to this all line. You absolutely can. That's fine. Nothing's wrong with that. What color is my dots?
Same color as the-
They're both the same color.
Woo, that drives me nuts. I can't do it. So I have to change it. So let's click on that trend line. Once you double click on that trend line, it'll bring you over here to where you have this format trend line. And then you can come right here. That's trend line options. These are effects. We're wanting to fill in line. We're going to change that color. See where it says color here? Yeah, we got to change it to something. I want something completely off. I mean,
Red.
I don't want matching. I like red. I think somebody said red. Whee! Doesn't that look a lot better? Because now those blue dots are really sticking out to me. Alright? Now in this, there's something else that's missing. You need to get that formula. That y equals. So in order to do that, right here where it says trend line options, you need to just grab the little cursor and you just need to scroll down. And as you say this display equation on chart, just click that. And it's going to throw it up there for you. I'm pretty sure I just clicked that. There we go. Now this is a problem. I'm going to go on and address this. So let's go on and exit that format trend line. A lot of professors will look at you and say where they want this at. Some professors, they want it actually right here with it on the graph. But that drove me nuts. I really don't like that because I think it's a little too busy. I like it to sit out by itself somewhere, so I'm going to stick it right here for right now. And I'm going to use this as an opportunity. If you go to college and a professor tells you to stick your formula for your trend line at the top left of your graph, guess where you're going to stick that bad boy? At the top left of that graph, because that professor is grading you. It doesn't matter what Mr. Hall said. Or fool you on him. Do what the professor tells you to do. Now we got a problem. We still don't have a key for this chart yet, so we need to go over here to add chart elements. Boom. Drop it down, and you're going to be looking for legend. I hate if you put it to the top, but look at that. That looks so busy. I hate when you put it to the left. I don't like it. I just don't. And I don't like when you put it at the bottom, because then it makes the bottom look really busy. But I like it over to the right. I don't know why I like it to the right. I just do. So I want you to put it to the right. You're going to click on that. It's a very nice representation, isn't it? Now this is what I want you to do with yours. You're going to slide. You can slide this up to leave it wherever you want. I'd probably, if I was doing this for a lab, I'd slide that up. I'd grab this formula, and I'd slide this formula down over here. Now with this, I want you to know that you can actually size this up. So you can make this whole thing bigger. Cool. Don't want to make that much bigger. Alright? I know you're putting your stuff away, I'm telling you, you better keep listening. You can even slide this over, the actual graph, and make the graph bigger. I would actually make the graph a little bigger. I'd center that back up. I would pull this back because it's going in that linear line. And you do this because you can now take this whole graph, you can go Control-C, or you can right-click it and say copy, and you can go into a Word document, which is what you're going to be writing this on. And you can paste it. Control V, paste it in there, and that document, it's there for you. That's what you created for somebody to see it. Doesn't that look so pretty, guys? That looks so nice, doesn't it? I'm going to tell you right now, you best be careful on this formula right here. That y equals, look at the y. Y is not what you should be solving for. X is what you should be solving for. Use your algebra. Now to give you a breakdown of these lab reports that you're going to have to write. In your lab report, you're going to have to include a cover letter. And I know nobody's listening to me right now. It's driving me nuts. This may be boring to you, but I'm telling you, it's going to help your grades unless you don't listen, and it's going to kill your grades. Your cover letter should look like, your cover page, however, should look like this. This is how I want it. I want the lab report name. You need to create a lab report name. It needs to be something besides lab report. It needs to have an actual name. Then you're going to put the class name. With the class name, you need to put the period. So you should be putting 5th period chemistry. Then you're going to put the student name. That's your name. And then the abstract would go on there. My recommendation is for your abstract, wait, do the report. Once you're done with the report, then do the abstract. Because the abstract is this big summary of everything that you're saying. But it's small. It's short. This should be short and to the point, but it shouldn't be too short. You shouldn't look at me and say, we measured sugar concentrations within soft drinks, and they have sugar. If that's your abstract, you're getting nothing. Okay? You actually need to give a summary here. Then going out of that, here. I gave you this sheet also. This is your chemistry lab report, what it should look like, okay? I wrote in here to give you some information and stuff that you can read later on. You need to have a running header. At the running header, it should have your name at the top left, the lab report title, so whatever your title is, should be there, and then you should have a running header with the page number of it. In here, every one of these bold sections that you see should be in there. You should label it clearly by itself. Okay? Every one of those. Now in this, your introduction should be an introduction to the lab. Why are you doing what you're doing? What's your hypothesis? Your material section. That is the most simple section. Label in there stuff that you use. You say, these are the materials you have to have in order to do this lab. Your procedure is what you did. Do not include pronouns or identifying nouns. He, we, she, our lab group, blah, blah. It's dry and to the points and to the facts. Data and data analysis is where you will include the data. And you will talk about the data. The results is where you really talk about the results. The conclusion is where you draw your conclusions. This is not a summary. Besides that, you got the stuff you can read. Tomorrow we'll be in Lab 1110, so you can start on these. Have a great, fantastic day.